So in this video, we are going to see exercise 2.1 from chapter number 2, polynomials. So there are total 3 questions here in exercise 2.1. Let's see one by one. So first, let's see. Okay, let's bring this down. So this is our question number 1. Let's try to read the question number 1. Which of the following expressions are polynomials in one variable and which are not? State the reasons for your answer. So quite a simple and straightforward question. We have to find out which of the following are polynomials in one variable. Now to quickly revise, what are polynomials? Okay, polynomials are expressions, algebraic expressions where exponents or instead of exponents I'll say powers, where powers of variables are whole numbers. This is an important point. Okay, all the powers of all the variables in your algebraic expression should be a whole number. So let me in fact highlight it. It should be a whole number. Okay, now using this definition of polynomial, we can easily figure out which of these are polynomials and which of these are not. So let's look at the first example, 4x square minus 3x plus 7. So as we can clearly see, okay, if we zoom in, we can clearly see that all the all the algebraic expressions have exponent or have their power as whole number. So yes, this is a valid polynomial. Now, next we come to this y square plus root 2. So one important point is we have to look at the exponents of variables only. Okay, so root 2 is a constant, so that is to be excluded. We have to only focus on this variable whose exponent here we can clearly see, whose exponent is a whole number 2. So yes, this is also a valid polynomial. Next, we come to this expression number 3. Now here we can clearly see that this 3 root 3 is nothing but t raised to half plus, so this will be plus t root 2. Okay, so now as we can clearly see, this is the expression. Okay, this is the variable whose power is not a whole number, it's a rational number 1 by 2. Root 2 can be written as t to the power 1 by 2. So the exponent or the power of a variable is not a whole number, hence this is not a polynomial. Okay, next we move to example number 4, y plus 2 by y. Now once again we need to express this in the form, so I'll just use a different color. So this is y plus 2 divided by y can be written as 2 y raised to minus 1, or y to the power 1. Now once again, if you focus on the exponent, here the exponent is 1, which is a whole number, but this exponent is minus 1, which is not a whole number, it's a integer, it's a negative number. So again, this is not a valid polynomial, so we cross it out. We want the powers of the variables to be whole numbers only. Okay, whole numbers means 0, 1, 2, 3. I mean, we all know it, just 0, 1, 2, dot, dot, dot. These are our whole numbers. Now, last is this example number 5, x to the power 10, y to the power 3, t to the power 50. Now, we are looking for polynomials in one variable. Okay, here you can see clearly there are 3 variables, x, y, and t. So, hence, although this is a valid polynomial in terms of the power of the variables, but we are looking for polynomials in one variable. So this is a polynomial in 3 variables. So this also will get striked out. So thus only first and second are the valid polynomials of one variable, and third and fourth and fifth both are invalid. So this is the answer for first question. And okay, let's strike it out, clear this up. Now next we go to question number 2. So let's bring it out. Yes, this is our question number 2. Let's read it. It says sorry, it reads, write the coefficient of x square in each of the following. Okay, so the term to focus on is x square. So this is the x square in first, this is the x square in second, this is the x square in third, and there is no x square here. Okay, there is no x square in the fourth term. So quite simple and straightforward. We have to write the coefficient. Coefficient is nothing but the constant that is attached to the variable. So in this case, the coefficient is 1. Okay. In this case, the coefficient is -1. In this case, the coefficient is pi by 2. And in this case, there is no x square, so the coefficient is 0. So these are the 4 coefficients of x square in each of the following term. Quite simple and straightforward question. So just clearing it up. Okay. Now the third question is as follows. Let's read it up. Give one example each of a binomial of degree 35 and monomial of degree 100. So let's highlight these terms, binomial and monomial. So what is a binomial? Binomial, as we have seen, is a polynomial. Okay, it's basically a polynomial with two terms. Okay, with two terms. Hence this word, sorry, hence this word bi. Okay, this bi is for two, and mono stands for one. So monomial is a polynomial. It's a polynomial with, sorry, with one term. Okay, it's called a monomial. And the trinomial is a polynomial with three terms. So based on the number of terms a polynomial has, we have monomial, binomial, and trinomial. Okay, so we understood what is a binomial and monomial. Now there's one more condition that we have to follow, and which is degree should be 35 and here the degree should be 100. Now once again, to quickly revise, what is the degree of a polynomial? So I'll just write it down here. Degree is the very simple definition. It is the highest power of a variable. Okay, highest power of a variable in a polynomial is called as a degree of that polynomial. So now, which means that we have to give one example of a binomial of degree 35. So binomial can have two terms. So I'm going to just write down the answer here. Okay, so where to write it? Okay, so binomial will have two terms. So let's say x35 minus x34. Okay, is this a binomial? Yes, because it has two terms. Does it have degree 35? Yes, it has a degree 35. Another possible example is x raised to 35 minus 5. Okay, this is also binomial with degree 35. Another example is x raised to 35 minus 2x square. This is also binomial and it also has a degree 35. Similarly, there are infinite such possibilities of a binomial with degree 35. Okay, now let's move to the next one. The next one says we want a monomial of degree 100. So this is simpler than the previous question because monomial has only one term. So we are just going to say x raised to 100. That's it. There cannot be any more possibilities. The only thing you can do is you can change the variables. Maybe you can say y raised to 100 or you can say z raised to 100. But it's a monomial, so it will have only one term and the degree is 100. So here the degree is 100. So this is the answer for problem number 3.